All right, we're going to look at slope fields again, and we're going to think about particular solutions, but also we're going to look at general solutions as well. So if you look at this slope field, remember it was generated by a differential equation, which means an equation that involved a derivative. And if I impose certain conditions, if I say that, okay, so I have some differential equation, dy dx equals some function involving x and y. Suppose that happens. So if I have dy dx equals this, but I say that the solution to this has to go through 0, 1, that would be this point here, then I can have an idea of what the solution looks like, and it would follow these slopes, and it would look like this. I mean, not exactly, but it would seems to go down and then get closer and closer towards this asymptote. It's kind of like this is like a current. It's following the current. I don't ever want to go perpendicular to these slopes. I just want to have my curve look like it has the same slopes as the slope field suggests. So this would be something like that. It's close. And then this would be something like that, and it would get closer. That, to me, looks like an exponential equation. So maybe I would have like y equals e to the x as a solution. However, I don't know. I don't know yet. I would have to have the exact differential equation that generated this slope field to figure that out exactly. But I could guess. So this is called a particular solution, and this is called an initial condition. So if I just said in general, what does the solution look like? Well, that would involve me thinking of all of these possible, like there's initial condition there, so it would be all of these possible curves. And so we would get something like y equals e to the x plus c, or something like that, or e to, something along those lines, maybe c, whatever, where there's some kind of constant that we don't know about. If I had an initial condition that was down here, then my curve would actually look like this, and that would be the solution to the differential equation. So it's not both of these at the same time. Some people get confused with that. It's one of them depending on what the initial conditions are. So if I were to ask, what would be, well, let's write it down. What is the range of the solution with the initial condition that the curve passes through 0, 1, just like I was saying, for x greater than or equal to 0. So I'm thinking of a range of some function, some solution, and it's for the slope fields above. So what I'm going to do with this is I'll plot my point, 0, 1. 0, 1. So I plot this, and then I follow the slopes, and I just generate my particular solution. Looks kind of like that. And it says, the question is, what's the range for x greater than or equal to 0? So now I'm thinking, well, to me, it looks like the range is actually from 0, not including 0, all the way to infinity. However, this is not what the question is asking. It's asking for x greater than or equal to 1. And it's for this particular solution. So this would end up being, well, I guess from this side of the graph, that would be, the smallest point would be 1. And we're including when we plug in 0, so we include the y-axis. So that would be from 1, including, all the way to infinity. So that's the range. Well, if I changed this point to, say, like, I don't know, something down here, if I said 0, negative 1.5, then that would be this curve, right? And it looks like I would have something that goes up, and then it gets closer to looks like an asymptote, to the x-axis. Then the answer here would be, if I had the same conditions where I'm looking at x greater than or equal to 0, then I would have from here, well, I would start at this point. The lowest point would be negative 1.5. And I do include it because that's on my y-axis. And I go all the way till 0, it looks like. And I would say it doesn't include 0 because it looks like an asymptote. So there we go. There we go. That's how you do that. So let's think about this one. What is the range? So let's look at the original. So if this was the conditions, that would be the range. That's all that I'm saying there. What is the range of the solution with the initial condition that the curve passes through 0, 1? So let's just do that one, 0, 1. And it looks like this is a weird one. I don't actually recognize this one as easily. Like the other one looked, oh, that kind of looks like it goes to that. I don't know. I feel like this one's going like this. Maybe it's a hyperbola. Maybe. Or something. I don't know. But that's what, to me, that's what this would look like. And again, we're looking at the same thing. The range, the y values. So for x greater than or equal to 0, that's this side. And it looks like I actually can't tell what the lowest point is. So this was a bad question to present. But if I had to guess, I would say something like if it started at 0, 1, I might say that it looks like the range would be, I don't know, somewhere in between like 0.8 or something. I'm just going to say including 0.8, 0.8. This is a guess because this is a bad question to be precise with. And then it looks like it goes all the way up into infinity. I'm saying that lowest point. This is not necessarily the lowest point because it looks like the slope is negative, so it would be decreasing, which means it has a smaller, I guess a smaller minimum. So it would go from there to there. Better one to have picked was 0, 0, because then I'd know. Yeah. Anyway, there you go. And we'll move on to the next video. That's hopefully ranges of, I guess, particular solutions to a slope field or a differential equation that generated a slope field.